welcome to Excel Academy. So today we are going to study the problems of set transform. So that is the very first problem that we learn. This is a basic problem we all have to learn, and then we'll move on to further, right? So we are going to learn about the very first problem, that is your x of n is equal to, that is your alpha to the power of n into u of n. This is what you are going to learn, the very first problem, the basic simple one, and then let's move on to the complex ones, right? So my given x of n is this. So first step, what I have to do, step number 1, we are going to learn step by step. So yes, just a second guys, I'm sorry for the interruptions. If any interruptions happen, please don't mind. So see here, step number 1 is what is, we've already learned one derivation in yesterday's class, right? In that particular derivation, what did we do is, we just got an equation x of z. So what is x of z? That is what is here, what I can say, the z transform of x of n, right? What is that? So that is a summation of, that is what, n is equal to minus infinity to infinity. That is what I can say, here x of n into z to the power of minus n, right? So yes, you got it right. It is x of n into z to the power of minus n. So this equation, what you have to do is, you have to take this particular equation into consideration now, and you are going to substitute the value of x of n for this equation. So in this particular x of n, what you are going to do is, you are going to replace it with this, right? This is replaced, right? So now let me replace that. So see here, very first what you have to know is, you need to know this particular x of z, and then here you are going to substitute in the place of x of n, that is alpha to the power of n into u of n. So as that u of n is equal to 1, so you can keep it, you can just write it as 1, right? Yes. So now coming on to the summation. So your summation now becomes equal to what? That is n is equal to, what I can say, this 0 to infinity, because your u of n starts from 0 and your amplitude is 1. So that is why. So now you get alpha to the power of n into z to the power of minus n, right? So I guess you got it till now. So see, what did we do? The very first step, so we took the expression, that is x of z expression, that is equal to, that is n is equal to minus infinity summation of n is equal to minus infinity to infinity, that is x of n into z to the power of minus n. That is the basic equation, that is the z transform of that is x of z, which is the z transform of x of n, and then that we are considering. And what did we do in the place of x of n here? What did we do? We just substituted this alpha to the power of n into u of n, and now I got this resultant, right? So this is what is till now, right? So for all the problems, you need to make use of this particular equation, and in the place of x of n, what is the given x of n in your question, you are going to substitute, right? Yes. So now coming on to this, I'll rewrite this particular equation again. So that is, when we substituted, we got it as, that is n is equal to 0 to, what I can say, the infinity. So that is your alpha to the power of n into z to the power of minus n. So now next step, what you are going to do after the substitution, so what I am going to do is, that is, you get summation of n is equal to 0 to infinity. So that is what you get. You have to what I can say, take n as common outside, that is like it is alpha into z to the power of minus 1, that is whole to the power of n. You have to take it like this. So why z to the power of minus 1? It is because you have z to the power of minus n. So if you remove n outside, so you remain with minus 1. So see here, if you remove n in alpha, so it would become equal to alpha to the power of 1, right? But in the case of z, it does not happen like that. So it is z to the power of minus n. If you remove n outside, so you remain with minus 1. So if you remove n, it is 1 only, but as there is a minus associated with n, so that is why you have to write it as minus 1, right? You got it right. For alpha, if you remove n, it is 1 only, but for z to the power of minus n, if you remove n outside, so as there is a minus associated with it, so if you remove n, it becomes 1, so therefore it is z to the power of minus 1, right? I guess you got it now, right? It is really easier. So now coming on to what I can say, the next one. Yes, so coming on to my what I can say, yes. So yes, coming on to the next step. So now next step, what you have to do is, I'll write the next step. So here you got one particular expression. So what is that expression? This, that is n is equal to 0 to infinity, that is alpha to the power of what I can say, the alpha into z to the power of minus 1 whole to the power of n. You got it right. So now you can see that this particular is in the form of the expression, that is a summation of n is equal to 0 to infinity, that is what I can say here, alpha to the power of n, right? Isn't this in the form of that? Yes. So what is this equal to? So this is equal to 1 divided by 1 minus alpha for, that is your what I can say, for that is your alpha that is greater, for alpha that is lesser than 1, right? For this particular condition, alpha modulus of alpha that is lesser than 1, right? So you got this particular slide, right? In this slide what we did, so here we just wrote that particular what we wrote in the last slide, and now what did we do is we just removed n outside and we just got like alpha into z to the power of minus 1, that is whole to the power of n we got. And what is that we did is we got to know that this particular was in the form of what I can say, the summation of n is equal to 0 to infinity, that is alpha to the power of n. And so therefore, so for that equation, what is the resultant is this, that is the summation of n is equal to 0 to infinity, that is alpha to the power of n was is equal to, that is 1 divided by 1 minus alpha, that is if your modulus of alpha is lesser than 1. So now what we are going to do is we are going to substitute the alpha, this particular thing over here, right? So now let me substitute this particular thing over here, and we are using this formula and we are substituting this particular to here, right? So now if we do that, a resultant would be what? Our resultant would be what I can say, that is your yes, I'll write that. So that is your x of z will be is equal to what? Your x of z will be is equal to what I can say, the 1 minus 1 divided by 1 divided by 1 minus, that is alpha z inverse, right? I guess you got it right. After substituting, after using that formula there, you are going to get the resultant like this. So a resultant like this. So now if you are alpha, for this resultant, if your alpha z inverse, that is your alpha z inverse is what I can say, the lesser than 1, right? I guess you got it right. I'll repeat this again. So when we have got a expression, so which was equal to alpha to the power of n. So we know the formula of alpha to the power of n, that is 1 divided by 1 minus alpha for your alpha modulus that is lesser than 1. So therefore if we use that formula and do the substitutions, your resultant would be is equal to, that is 1 divided by 1 minus alpha z inverse. So that is if here what I can say, your modulus of alpha z inverse, that is alpha z inverse is lesser than 1, right? So now we are considering this particular, and now we are going to find the ROC. But before finding the region of convergence, let us find out this particular, right? So simplify this particular. So we get it as 1 divided by 1 minus alpha by 1 by z. So your z inverse will be what? Your z inverse will be 1 by z. So therefore now we are going to get it as 1 minus 1 divided by, that is alpha by z, and next you are going to get it as that is what I can say 1 divided by that is z. So I'll rewrite this, just a second guys. Yes, so I'll rewrite this in really smaller manner so it would be easier for you. So now if you simplify, you're going to get it as first thing that is 1 divided by 1 minus alpha into that is 1 by z. So what is your 1 by z? That is z inverse. So if you multiply here, you're going to get it as that is 1 divided by 1 minus alpha by z. And the next step what I can say is it is 1 divided by that is what I can say you're going to take your z as this thing, and what you have to do is you're going to, so what is z into, here it is 1, so what is z into 1, it is z. So here what is 1 into z, so if you want z, so your 1 into z is z, so therefore here if you multiply z you're going to get it as z, so that is z minus alpha by z. And what is that, if you bring z to the upper part, so you are going to get it as that is z divided by z minus alpha. So this is what is the resultant that you get, right? You know to do this particular, right, that is your 1 minus alpha by z, you know, right? So you're going to take z as common and you're going to multiply, so this is 1 into z which is equal to z, so therefore that z you're going to multiply with 1, so you're going to get it as z, and here it is z into 1 and that 1 you're going to multiply to alpha, so you're going to get z minus alpha by z, right? I guess you got it, right? And now let us come to this particular. So now in the case of the substitution, we got to know that on condition, that is if your modulus of alpha, that is z inverse, is what I can say that is lesser than 1. So therefore now let me simplify this. So what is the resultant? You are going to get alpha into that is 1 by z, so which is what I can say modulus which is lesser than 1. Or next what you are going to get, you are going to get alpha by z modulus is lesser than 1. So if you bring the z modulus to this side, so therefore you are going to get it as that is your alpha modulus is lesser than that is z modulus, or I can say that your z modulus is greater than alpha modulus. So right, so this is what is the resultant, and you got to know that this is what is the, what I can say the left is this is what is, you got to know that it is what I can say the right sided sequence. So this is right sided sequence. So if your z modulus is greater than alpha modulus, I can say that it is a right sided sequence. If your z modulus is lesser than alpha modulus, it is a left sided sequence, right? So this is right sided sequence. And what is the ROC for a right sided sequence? The ROC for a right sided sequence would be equal to this. So that is, you are going to draw the ROC, that is you are going to draw circle first, that is a ring that is centered at z axis. So this is RE of z, what I can say real part of z, and here what I can say it is a imaginary part of z. And then you can see that you're going to shade the ROC that is outside the circle, right? Yes, outside the circle. And this is what I can say this as my ROC, that is of what? ROC of that is x of what I can say here, n is equal to that is alpha to the power of n into u of n. So the z transform was what? That is z divided by z minus alpha. This is z transform of that particular, and your ROC is this one, right? ROC is this one. So now this is what is the very first problem that we learned, and we are going to learn the second problem in the next lecture, right? And thank you.